doesn't cut as well for. What you want is a bimetal blade. You get these at Lowe's, Home Depot. You can buy them online. Something like $1 to $3 per blade. If you get 10 blades for $3, you might as well take them home and drop them in the trash. Okay, because it just isn't going to cut it. A bimetal blade has very hard cutting material welded onto a substrate, and the substrate is flexible, but the cutting is very sharp and hard, and that's what you want. Don't skip on the blade. 24 teeth per inch is a good compromise. 24 teeth per inch will cut the aluminum sheet very nicely. It'll also cut the rectangular bar nicely. You can cut it faster if you get 18 teeth per inch, but one of the things when you find when you use a hacksaw, I know, is it wanders. When you use a hacksaw, it doesn't necessarily want to go straight. The finer the teeth, the less it cuts per stroke, and you have more of a chance to correct it. Okay, so there's always some sort of a price you pay when you do this, but get yourself a couple of decent hacksaw blades and you'll be fine. Don't skimp here. If you have a power saw of some type, great. A tabletop bandsaw or a big bandsaw or a scroll saw will work. You have to be sure to get a metal cutting blade. These things are usually sold with wood cutting blades. Get yourself a metal cutting blade, and the scroll saw can handle up to about 1/4 inch aluminum. It's slow. And I wouldn't buy a scroll saw just for this. If you would buy a saw, I would get the band saw. But if you got a scroll saw, you can try putting a metal cutting blade in it. And I don't have to tell you to be careful. These things have guards and so forth. You can literally cut your fingers off. So safety, safety, safety. When you're pushing material into either of these, you never, ever, ever, ever push it with your hands. You take another piece of wood or material to do the pushing. So if it slips, that goes into the blade rather than your hand and your fingers. Okay, I've had, not myself personal experience, but I met a guy who lost 3 fingers in a bandsaw. Okay, and he had them sewn back on again, but boy, you got to watch it. Okay, a jigsaw, that's the one that, you know, goes like this. And the reciprocating saw, the one you get holes in walls with, no, they're too uncontrollable. I don't recommend them for it, but you don't need any of these. A hacksaw will work fine. A hacksaw will work fine. I know because I did it. Okay. One thing though that you got to have, you have to have this little combination sander. It's got a 1 inch by 30 inch belt and a 5 inch disc. That might look like it's an enormous machine. No, it's this wide. It's about a body width wide and about an arm length or less in height. You can lift it up easily, shove it under someplace if you don't want to use it. It's not going to get in the way. I keep mine out. Once you get one of these, you wonder how in the world you ever survive without it. You can sharpen tools on it, sharpen knives on it, sharpen chisels, but you got to have it. Okay, you have to have it, and you'll see why. All right, you have to have the abrasive has to be about 120. If it's finer, you get a beautiful finish, and it takes forever, and it gets hot. If it's coarser, it cuts faster, but you get a rougher finish. So I have a bunch of belts around. The belts are easy to change. But 120 seems to be found, seems pretty good for this kind of stuff that me or a ham or a QRP here would use. Small footprint, that's not expensive. I've seen them for 85 bucks. I've seen them for $85, okay? I've also seen them for $200. I can't figure out why they're $200 because I didn't pay that for mine. Once you got it, you wonder how you're ever going to use it. You have to be able to drill and tap holes. This is something many of you are probably not familiar with, okay? And I assume that you have a variable speed drill, okay? Not one that just comes on and off. When you have to precision drill a hole, you got to be able to start it slowly and then bring it up to speed, okay? A variable speed drill and a set of drill bits from a 1/16 of an inch up to a quarter is just ideal, okay? And as you can guess, you get better bits, they last longer and so forth. But these are readily available just about everywhere. But what you don't find everywhere is a drill and tap set. When you're going to thread a hole, you have to drill the hole to a very precise dimension, okay? And numbered drills change by just a few thousandths with each one. The drill for a 440 screw is a number 43. If you try to use something else, the threads either will be too weak, or worse yet, it'll be too small. The tap won't go in and it'll break off. I've seen these on Amazon, a drill and tap set. They're typically $5 for the set. You can get the tap and the drill that goes with it. And you know what? What I've done my whole life is I know I'm going to break something and I know I'm going to lose something. So I buy extras. I pay an extra $5 and I'll get 2 of those. You need some sort of a wrench to turn that little tap there. And the one that I happen to like is called a T-wrench. There's another type, which is just sort of a straight bar that you screw on. You know what the trouble with that is? It's real easy to twist it too hard. And get what happens when you twist it too hard? It breaks off, and guess what's stuck in your hole? Okay, then you have to try and get it out, okay? Again, I've seen El Cheapos for $5 on Amazon. If you want to get a better one, go ahead. And absolutely, you need this device here, which is called a center punch. Center punch is a piece of metal, any kind of a punch is a piece of metal that's long, and it has a precision point made on it, and the thing is treated and hardened. And so what you can do is you put it into the metal and you hit it with a hammer and it puts a tiny crater in the aluminum. And when you go to drill that little crater holds the drill bit in position, so it doesn't go all over the place. Here's your beautiful front panel. And here's this streak across the front. Yes, it's happened. Yes, in the early days, this happened. You need a good center punch, all right? Again, I think I've seen these for $5 or $10. You've got an initial investment here if you haven't got them, but once you got it, you're there. Okay, did I not? There we go. Other tools you're going to need. I assume you have a hammer. Is there anybody that doesn't have a hammer? If I had a hammer, I'd have a hammer in the morning. You need a hammer, normal workshop tools, screwdrivers, things like that. A vise is really handy. You got to have some way to hold the metal. Okay, you need, especially when you're drilling it. Especially when you're drilling it. If you use a drill press, how many of you have handheld stuff in a drill press? And how many of you have almost cut off your fingers doing this? Okay. Yeah, it grabs and that big motor will rip that thing around. When I first got my drill press, I said, okay, rule number 1, we don't handhold in the drill press, okay? You need a square. And that is technically a wood square, but it's perfect for our purposes. You can get these at Harbor Freight, or you can also buy it online. I've seen them sold separately online out there, okay? You don't have to have it, but if you haven't got one of these, once you have it, you'll swear by it. They make these 6-inch stainless rules. It's a 6-inch ruler. It's made of stainless steel. General Tools makes them. They're graduated in 64ths of an inch, and they're all of $3 to $5. And it's a little ruler instead of a foot-long ruler. It's ideal for what we're doing here. It's so handy while you order any stuff. Why not throw one of those into the kitty too? Okay, it's Christmas time. Put that in your stocking. Okay. Okay, there we go. Now, the method of construction. What you can see here is that the sides down here, that's made of the aluminum bar. That's 3/16 very rigid aluminum bar that is thick enough that in the sides you can drill and tap holes. The front, the back, and the top and bottom are the 1/16 of an inch aluminum sheet, and that you just drill holes through. The problem is getting the holes in the sheets to match up with the holes in the bars. Okay, that's the secret I'm going to show you here. Okay, it can be done. If you got a milling machine like I have, oh heck, put her in there, there you go. But you don't have milling machines, you don't have all these precision tools, but it can be done by being clever. And then you fasten it all together with 440 screws. So let's see. Okay. Hope we went back. Okay. Okay. Press and hold. Okay. Modus operandi for all you Latin lovers out there. Is it Latin? I think it's Latin. Latin. It means the manner in which we're going to do things. What you do is you saw the metal to the approximate size, and then you sand it to the final size. You cannot do precision work with a saw, even with wood. See, wood compresses, wood bends, you know, if this isn't quite, I can force that down. You can't do that with metal. It's got to be accurate. You saw the metal to the approximate size, leaving a little bit extra on, and then you sand the extra off until you get a beautiful finish. That's why you need the grinder, okay? And then you drill and tap the holes to hold it all together. The order in which you do it is you do the sidebars first, because they're the easiest. They're the easiest. You use this 2-inch wide, 3/16 aluminum to make the sidebars here. You can see on this, they're right there. And then you set them aside. And after you have made the panels, and after you have drilled the panels, then you use the panels to determine where you should make the holes in the sidebars, and you do that last. That way, the holes in the sidebars match the holes in the panels. Okay, and that's the problem with the hole. I see some smiles out there. That's the problem with it. When the hole is here and one is here and the other one's here, you can't just force that over there. Okay, you can also use the sidebars to help measure the top and bottom panels. See, so you use the parts to measure the other parts, and that makes it a little bit easier. You choose the dimensions. It's up to you. Depth, width, panel height, that's all up to you. The height of the chassis is a little bit bigger than the bars because the aluminum is a 1/16 of an inch thick. When you stack it on top, you add 1/8 of an inch to the height, but I don't think anybody's chassis has to be that accurate, right? I cut my bars to 3.5, 4.5, 2 inches, whatever. This thing can be made very small. I've got one keying amplifier that's only about 3 inches by 2 inches. And it's so rugged a truck could drive over it and wouldn't even know it happened, okay? It's amazingly strong. I put this one in on my wife's recommendation, okay? Something that seems to be lost on so much of the younger generation now. Practice, practice, practice. You don't just achieve it all at once at the first time. You're going to screw up. Okay, as long as you screw up and don't hurt yourself. All right. Before you take a piece that you've worked hard on and work on it, you practice on a scrap piece of metal. Okay, especially when it comes to drilling the deep holes in the sidebars. I'll talk about that. Don't be afraid to practice. That's also the thing in music. Practice, 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 and practice, practice, practice. When you cut the sidebars, those are the sides. The sidebars are the side of the piece. You cut them, the final thing is 1/8 inch more than the sidebar length because you put the front and back panel on. That's not usually a consideration. But if you're trying to make something fit in a cubby hole in a nice ham shack, well, maybe it is. I don't know. Whenever you draw things, folks, you use a square. You use a square. You don't trust your eyeball. You don't trust your eyeball. I have a United States standard square. Cost me so much it's ridiculous, but it's so square that over 5 inches, it's not more than 3/10,000ths of an inch off. I use that to check my squares, but you don't need that kind of precision, okay? You use a square to draw a sharp line as close to the unfinished end as possible. You go out and draw another line. When you draw your lines, don't use magic marker. It's too wide. Use a sharpened pencil. If you try to use a mechanical pencil, you usually can't press a mechanical pencil hard enough to mark the metal. So you get, yes, a number 2 pencil, one of those yellow things, right? And then you also have to get a pencil sharpener, okay, that you can sharpen with. That's at Staples, okay? So here's what I've done. I've taken the square against the aluminum, and you can see on the left end there, I've brought this is pretty ragged end. I brought it as close as I dare. You can see that the end is quite ragged, but I've got as close as I can so that every bit of that can be sanded off. And that's what you're going to do, is that'll bring that square. Then I moved it over 4 inches and drew another line. And then you place this in a vise, as you can see there on the left, and then you hacksaw it off. Now, how many of you know that you're supposed to put the hacksaw blade in the hacksaw frame in a particular direction? Okay, it's supposed to be so that it cuts when you push, not when you pull. It's cut, 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 not the other way around. Okay, and take your time. Usually the cut will not be straight, but if you twist the frame, you can gradually force it to get straight. Okay, practice again. You don't want to cut into the line that you drew or past it. You want to be able to sand it off up to that line. So there's what that piece looks like after I've cut the right edge. You can see that it is not a straight cut. It's thinner in the middle and it's a little bit thicker at the edges. That's perfectly fine. You want to leave more on there, that's okay, but then it just takes that much longer to sand the darn thing down. But hey, that's the way it is, okay? Then, before you do anything, you have to square up the machine, okay? You have to adjust the machine. In particular, with these sanders, for the belt, there's a little piece, it's hard to see in the picture there. There's a little piece of metal behind the belt called the platen. And when you sand with it, you push the belt, you push the material into the belt, and then the platen behind it keeps it from going anywhere. The platen should be parallel to the belt. The belt shouldn't be here and the platen like this. It should be parallel. You may have to undo the screws below it and bend it, however, to set it. And then you want to be sure that you can move it back and forth. So you don't want the belt here and the platen here. You want it just kissing the back of the belt. You want minimum movement of the belt when you come in to sand it. Then you take the ruler out of your square. You lay the square on the table there so that it's sitting on the table, and you adjust the angle of the table so that the square is parallel with the belt. If you don't do this, when you use the belt to sand the end, your end is going to be angled instead of straight. And I don't have to tell you that when you try and take an angled end and put it near a straight end, it's not going to work. You have to square up the belt. And the same thing goes for the table, for the disc. You put the square on the table for the disc, and there are usually two adjustments there on these things, one in the front and there is one in the back. You loosen them and you adjust the table so that the square is against the platen for the disc and rests on the table, and everybody is happy and square there. And then you lay it down, and there's usually a guide here that you can use to hold the piece there, right there. That guide is on the right of the square as it's laid down. That thing has got graduations on it. Ignore them. In fact, on most machines, unless you've got a very expensive machine, you can ignore any degree markings on them because they're almost always off. But you square it up this way, everybody is going to be happy. Thought I had this figured out. There we go. And then you start the machine, you put your piece on there, and then you move it back and forth and sand off the end up to the line that you have drawn. You may have to apply some pressure there. And I have a movie here. Did we just do that, Andy? Let's see if it goes. You move it back and forth while you are sanding. You don't just shove it into the disc. And hold on. There we go. You move it back and forth, and you do not use the back part of the disc. You use the front part of the disc where the abrasive is moving down. Otherwise, the stuff you're sending off is flying in your face. And if you haven't got eye protection, you've got all this metal dust in your eye. Safety and common sense, okay? There we go. You do both ends. And it may get so hot while you do that that you have to let it go for a while. Take it out, let it cool down. Don't force it. Let the machine do the work. The machine work, let the machine do it. You're not supposed to be doing it. The machine's supposed to be doing it, okay? Then, now that you got your bars done, you set them aside. You set them aside, and you work on your panel dimensions. You choose how wide you want your piece to be. How wide you want that to be? All of your panels will have that as one dimension. All four of them will be that same dimension, and you must make them to that same dimension. You must grind them to that same dimension. Not hard, okay? Then you decide how wide you want them. For the back, the height is exactly 2 1/8 inches because it's 2 inches plus the extra 16 for each of the sheets, okay? For the front, whatever you want, if you want anything at all. For the top and bottom, the depth, the other dimension, is exactly the same as the bars you just made. They have to be made exactly the same. So you can actually use the bars as rulers to make sure that they're the same. That's one of the things that you want to do. Now, I'm assuming I might be patronizing here, but when you measure the panels, I wonder how many of you would pass a test I gave of asking you to draw a good rectangle on a piece of paper. Okay, it's not as easy as it sounds, but you use the square to draw a rectangle of the right dimensions on your stock. Use a straight edge, and then you draw verticals. You measure the required distance, and you connect the verticals at the top. Now, let me just do that. So here's a fresh sheet of aluminum that is straight on one edge. If you haven't got a straight edge, then you got to make one somehow. But all I did was I set this square to 4 inches, and I laid it down, and I did use a magic marker here so you can see it for the demonstration. But you should use a sharp scribe or a very sharp pencil. And I actually went around the end of the square like that. Then I moved it over, but I moved it until the right edge was the correct distance. In this case, it was 7 inches. And I used it so that the right edge here, and then I drew up on that and over, and then I connected the top. And then I had a rectangle there, all right? Then you cut it out with the hacksaw, all right? That may, however you do that, you figure that one out. After you've cut it out, you put it on the sander on the belt. You can't use the disc because the disc is going up and down. You only can use the front part of the disc, and that's not big enough. So you move this back and forth. Here we go with the movie, hopefully. I think we have to wait about 10 seconds or so. So we'll just wait. There we go. And I'm hardly taking anything off here because I was just doing the demonstration, but you keep moving that back and forth, keep the work moving, and you bring it until you've sanded off the excess metal and it's on the line that you drew. You do the same thing on the ends. I'm married. I've never had a problem with it. I figure if it takes the ring, it's going to take my hand too. I've never had. That's a good question though. Yeah, I've never known any machinist to take off his ring, but maybe I should. My wife takes her ring off when she does pottery, right, Teddy? Yeah. I'll get some questions at the end. Okay. Yeah. Okay. I'll get some questions at the end because I'm sure they're there. Okay. I guess I just go over here. Yeah. Now here's the part that's kind of tricky. This is where you got to be clever. Okay. This is where you got to be clever. First, you figure out where the holes are supposed to be drilled. Okay. That's not as easy as it sounds. Okay. Then you center punch those locations and you don't drill the hole in the panel out to the size of the screw. You drill a tiny hole instead. And you use the tiny hole as a guide so you can mark the side panels. See, if I give you a hole that's this big and I say, put a pencil mark in the middle, you're gonna, oh man. But if I give you a hole this big and I say, put a pencil mark in the middle, you're gonna be hard pressed to mess it up. So you drill a tiny hole, then you use the guide holes in the panels and a pencil to mark the sidebars, and then you can drill out the holes in the panel. You're going to use the panels to figure out where to drill on the sidebars. So here's how you do it. Now, this is the top sheet that I'm going to use. I'm working on the top sheet, on the very, very top sheet. I put the side panel, the sidebar on that straight and square. So it's on the outer edge and it matches up perfectly like it's supposed to be when assembled. And I draw a line with a sharp pencil, just like that. Then I draw lines perpendicular to that, 1/2 inch from each end. That's where the screws are going to be. Come in at least 1/2 inch. Don't get closer to the edges than 1/2 inch. Okay. You put in extra lines where you want your other screws. I typically want them about 1.5 to 2 inches apart. This thing was only 4 inches, so I put one more hole in the middle. Just draw the line, and then very carefully, you use the center punch by looking at it very carefully, and you center punch those lines right between the outer edge and the long line that you drew. These have to be exactly halfway in. That's the critical thing. If they're not halfway, when you try and put the screw into the sidebar, it's going to come out of the sidebar. All right. So this is where you got to have some precision. This is where you might practice. Okay. Screw one up royally. Oh, heck. Draw another line 1/8 inch away and redo it. And so that screw isn't exactly centered. Oh, gee, my life is over. No, you're going to make mistakes. You can do it. Okay. Then you drill 1/16 of an inch hole in each of those. See that? See that? And this is a good technique whenever you drill any hole. You take a larger drill bit, like 1/4 inch, and by hand, you put it on that and twist it to cut off any of the chaff that might be there on the top and the bottom. So there's no extra metal sticking out. That's a common machinist technique. Okay. Then we're almost there. You mark it with the pencil. You put put those holes, you put that together on top like this right here. Here's the bar and here's the panel, and you lay it up here on the top so that it's correct this way here and here. You can tape that if you want, and then you take a pencil and put it through those little holes so that you mark the sidebar. You could try and just center punch it, but that's going to screw up. So put the pencil mark on there. And then that's what the sidebar looks like. See those little dots there where the pencil is? And then you carefully center punch those areas like that. Dun, dun, dun. Okay. Now comes the second hardest part. You have to drill a 1/2 inch hole deep. My bet is very few of you have done that. I'm sure lots of you have drilled through a piece of metal, but drilling a 1/2 inch into a piece of metal is called drilling a deep hole. If you have a drill press, use it. One way, put some tape around the drill bit 1/2 inch from the end so you don't go too far. This is a cheap drill guy like that. And when you drill this, you can do it by hand because I did it. You hold it straight, obviously, and you're going to have to apply some force, but you don't just, it may stop cutting. You know what's happened? Well, I'm going to tell you. Okay. What has happened is those metal chips that are cutting out, they have to get out of there. And when you drill a deep hole, they can't get out. They plug up the flutes in the drill. And more importantly, one of them will probably get stuck on the end and block the cutting edge of the drill. You frequently pull the drill out, clean it off of any of those chips. And if you have a pocket knife, make sure that nothing is stuck on the end of the drill. And then you go again until you're a 1/2 inch deep. If you have a drill press, don't just, how do I know this? Because I've got broken bits until I learn. You bring it out, clear it off, put it down, in, out, keep it oiled. All right. That's standard procedure for a machinist, but for a typical person in the street, they don't know that. You put your tap in the tap wrench, you oil it, and you can actually hold the metal when you do this. You don't have to put it in a vise, but you screw the tap into that hole. The tap will guide itself in. Okay, it will straighten itself out and guide itself in. And again, you don't just force it in. You go in, you come out, you go in, you come out, you go in, you come out until you'll feel it bottom out. It'll suddenly stop turning. Don't go past that. Bring it on out and clear the chips out of the hole. Use air, or I just take paper towel and twist it up and shove it in there to get all those chips out of that hole. Okay. You got to do that for all the holes. I like doing this work. Sorry, I love doing metal work. If you hate this kind of thing, well, then this isn't for you. Okay. So I love it. There's the finished panel or the sidebar at the top. Then you drill out the panel to 5/30 seconds and you put it together. And when you put it together, it will wind up looking something like this. Okay, there it is, screwed together. And what you do, because the holes here have to match the holes there, you put a number here and here so that you know that this one goes with that one. Because if you don't do that, you get all these pieces and you go, oh God, which one goes with which? You'll be there forever. Then you work on the next end, the front and the back, and you work your way through the whole thing. Okay. There it is assembled. You'll notice that these screws hang out a little bit. That's perfectly fine. It isn't a perfect fit. That's perfectly fine too. This is handmade. You don't want it to be absolutely perfect. It isn't factory made. You need to have a little slop so that you can prove that you actually made it yourself. Finally, when you're done, what you have to do, you don't have to, but if you get some soft scrub cleaning compound for the kitchen and you rub it down, as you see there, you go from what you see on the left to what you see on the right. It puts a beautiful buff finish on the whole thing. If you're in need of agony, you can do what I do, is I use metal stamps and I mark my equipment by embossing the functions directly into the metal. This is difficult. This deserves a whole seminar on its own. But here's the kind of equipment you can have when you put it together. You don't tighten everything down at first. You keep everything loose. And then when you get all the screws in, then you tighten it down. There's my current project, which is a receive converter that goes with my 6x2 receiver. There's a small tiny box that I used for a CW relay, okay? That's only about 2 by 3 inches. There's a 1-tube 5-watt transmitter that I got from Jim Trutko. This is one of the originals. You can see how it was built. There's a 6146 amplifier, higher than 2 inches, obviously, but it still uses the same type of construction. A much bigger amplifier. There's my receiver. And just to show you that I'm not stuck in Tubeville, I'm interested in EME work, and this is the absolute opposite of Q. This is actually 1 kilowatt is pretty much QRP for moon bounce, okay? 1 kilowatt is QRP for moon bounce, okay? This is a 1 kilowatt LDMOS amplifier. There's a 1 transistor, is that white thing in the middle there, this one right here. And it only needs a 50 volt, 30 amp power supply to do it. You can make it big, you can make it small, any way that you want. Questions? Yes.
This was fun. My question for you, I have a 1-inch belt sander that doesn't count, it's on combo.
You can probably do it. You use a sidebar with the belt.
Back and forth with the demo video. How do you keep it from doing this so much, or is it just practice?
Practice? Oh, no, actually, no. His question is, when you're going back and forth, how do you know to keep from tilting it? You have a line scribed on it, and you follow the line, and you bring it down to the line.
It's going to go a little bit.
You're visually keeping it with that line. Yep. You could do that with the disc part too, but if you've got a guide to do that, what the heck? Yes, sir. That's true. Say again now. Layout fluid can be used. Layout fluid, it's kind of layout fluid is this blue stuff or red stuff that you can paint onto something, and it is made to be removed with layout fluid remover. I didn't discuss that because I figured most people probably don't have it. But layout fluid, you run it until you can't see the last fleck of blue or whatever on it. Yes. And you're right about the ring with a 50 amp, a 50 volt, 30 amp power supply. You're absolutely right. There was another question. Yes. Yes. Well, actually, for me, the tool to use, if you want to buy it, is a carbide scriber. You can buy a pointed tool, which is like a pencil, but it has a silicon or tungsten carbide tip on it that you can scratch into the metal. Yeah. That's brilliant. Yeah. He said you paint it with the layout fluid and then you scribe it with the scriber. That's good too. Yes. To braze it. The point of this one was to use screws because, again, brazing is something that I think a lot of these folks don't have. I mean, okay, let's get this straight. This isn't the only way to make a chassis. The usual way that they make them is they use what's called a metal brake, which is a device that's designed for bending metal. I have found that the small ones usually can't handle 1/16 of an inch aluminum unless it's very, very short. This is something that I think anybody could do. This is certainly not the only way to do it. Yes. Absolutely. Aluminum oxide is pretty much standard. But I think there's the question was what kind of abrasive? Aluminum oxide is pretty much standard, but there's a zirconium oxide or something like that. Most of them are aluminum oxide, and in most cases, the belts aren't very expensive. And so this is one of the things that's difficult with me. Don't be afraid to throw out a belt or a disc when it gets dull. They're cost $1 each. Don't try and use it past its useful life. Okay.
That's great. Thank you, Sean.
Thank you so much. You guys have been great. Yeah.